On this third part of our three-part series of areas between two curves, we are using the same formula, the same idea of needing to take the top function minus the bottom function, but in this set of examples, and there's only two, but in this set we have really interesting graphs that not only are we going to get our boundaries from because they're intersecting, but they actually intersect 3 times. And because of this, it's going to make it to where we have to do more with our integral than we're normally used to. So let's take a look at one of these graphs so you'll see what I mean. On this first one, we've got a cubic function and a line. And so in order for us to have 3 points of intersection, we're probably going to have a cubic function, and then we can either have a line or a parabola or some other ones, but probably one of them will be a cubic function, just because otherwise we won't end up with all of the up and down that we need to get 3 intersections. If I plug both of these into my calculator, into y equals, and look at the table of values, I can graph these. I would also suggest that after you plot your points for your cubic function, that you go back and look at the graph so you can see exactly what it looks like, because with cubic functions sometimes there's things happening at 0.5s that you won't notice unless you look at the graph, because your table of values doesn't automatically tell you 0.5s unless you want it to. So we're going to start with points for that, like 0, 0, and then -1, -2, and -2, -2, and so that's where we're going to have to look at our graph to see, like, does this go down really far in between these points or just a little bit, or what? Then next to that is -3, 3. On the other side, we've got 1, 1. And 2, -2. So we're going to graph this as a cubic function. So what happens is from 0, 0, it goes down to the left. It actually goes a little bit past right here and comes back up. Not a huge amount, but at least a little bit. And then it keeps going up this direction. Goes towards this point and then comes back down. Should look something like that. The other graph that we have is a straight line. It has a slope of -1, and it goes through 0, 0 because the y-intercept would be 0. So that means that we're going to start at 0 and just go down 1, right 1. And we want to do that so that we can see all the points where we might be intersecting. So if you could either draw a whole bunch of points to check that, or if you are careful about how straight your line is, that will work also. So if we look at this and we say, where is the area that's between these two regions? There's 2 different places that happens. There's a place right here that we can call between them, and there's also a place right here. And those are split up by this middle intersection point. And the reason this is significant is because if you look at just the left part of this, and you say, well, which function is on top? You'd put the -x on top of the cubic function. Because look at it, the line is above the cubic function. But then when we look at the right side of this, the opposite of that is true. Now our cubic function is on top and our line is on the bottom. So how do we deal with this? We're going to do 2 different integrals. And so our first integral is going to be, and I like to go from left to right personally, and most math teachers do. The first integral, this left part, starts at -3, because that's where this point of intersection is, even though my cubic function got a little wonky there. It starts at -3, and then our next intersection point is at 0. So our first integral is going to go from -3 to 0. We're going to do top minus bottom, and so for the first one, the top is -x. Then we're going to subtract -x cubed over 2 minus x squared over 2 plus 2x. And that's our first one. The other one is going to then start at 0, and it ends over here at 2, where we have this other point of intersection. And we're going to do the cubic function first this time because it's now on top. And then we're going to subtract the other function, the line, which is negative x. Now, we're going to go ahead and add like terms and distribute our negatives and all that stuff like what we've been doing in the past. And it's really going to be very similar to the problems that we've already done in the first two parts. It's just that we're going to have to do it basically twice, which is admittedly a little annoying, but that's just how it is. We're going to distribute the negative, which makes this be a plus, and a minus. The negative x and the negative 2x will come together to be negative 3x. This is still from negative 3 to 0. We are going to add x cubed over 2 because we changed the sign, and add x squared over 2 because we changed the sign. And then something similar happens on the second one here. This time I only have to change the sign for x. We'll have 2x plus x, which gives us 3x. When you're done with adding like terms and all that, because these two integrals have the same functions, they are going to look very similar. It looks like they're opposite of each other, actually. And so you may think, well, isn't there some way that we could do these together or something like that? And unfortunately, there isn't, because we're going to plug in different numbers, and that matters. We're plugging them into things with different signs, and that matters. So if you worked really hard, you might be able to find some sort of shortcut, but it would really probably be easier just to go ahead and work this out. So we're going to use the power rule on this, and then the power rule on this. We'll plug in 0 and negative 3 to the first part, 2 and 0 to the second part. So the power rule, we're going to add a power and divide by it. Add a power and divide on x cubed over 2, which gives us x to the 4th over 8. Add a power and divide, so x cubed over 6. Now all of this is the first one that we're putting 0 and negative 3 into. And what we're going to do is we're going to add that to this other one that we get, whatever it ends up being. And so our integral, when we evaluate it, is going to actually be the same as this, but just with opposite signs, because the functions were the same, but with opposite signs. So it'll be negative x cubed over 6 and negative x, sorry, that's that one, but I skipped the first one. So negative x to the 4th over 8, and then plus 3x squared over 2. Remember, the power rule is add a power and divide. If it already has a fraction, like these 2's, they already had fractions, so we had to multiply by what we were dividing on the bottom. Now we're going to plug all these in. Fortunately for us, they intersected at 0, so the part where we go to plug in 0 will be easy. Like, on the first one, I'm plugging in 0 first, and if I put 0 in all three of these, I get 0. When I plug in negative 3, though, I'll actually have to work out what that is, either by hand or in my calculator. So if I figure out what that is, that's the answer to this first part. And then the same kind of thing happens on the next one, except this time I'm going to plug in 2 first. And then I will subtract 0. So some of the things I'm doing here, like the parentheses I have, some of those parentheses aren't super necessary. They're only really necessary if there's a negative in front. And then the zeros you wouldn't really have to write, so you can shorten this sum if you want to. But essentially what we have left is this right here and this right here. So we end up with, when we work that out, let's see, this is negative, and we should get negative, sorry. I was looking at my work and I think I did it wrong the first time. So I'll just, let's just wing it. We're plugging in negative 3, and so that means that we have negative 3 squared, which is 9, times negative 3 is negative 27 over 2. this is 81 over 8. And then 27 over 6, negative 27 over 6, which we can simplify by 3, so that would be 9/2. That's our first parentheses. Our second one, which we don't really actually need parentheses now at this point if we wanted to drop them. I get 8 over 6, which is 4/3, and it's negative. I get 16 over 8, which is -2, and then we get 12 over 2, which is 6. So we just have to figure out what this is. If you haven't already pulled out your calculator to do this, that would be totally fine. I would kind of like to do that actually myself. I'm going to type in negative and in parentheses put negative 27 over 2 plus 81 over 8 minus 9 over 2. Close my parentheses and then I can do minus 4/3, like I don't need those parentheses there. Minus 2 and then plus 6, and I get 253 over 24, which I'm not sure how that sounds as far as an answer goes, but I guess we'll find out. So as long as we did everything right, we got 253 over 24. That was a lot of work to do that, but the main thing was that we just checked to make sure that since it switched, there are certain cases where maybe it doesn't switch, where we might not have to do that, might not have to split it up into two integrals, but since they switch at that middle intersection point, that's why we had to do two of them. Let's do another one. This time we have a cubic function, actually the same cubic function, and we are going to have a different second function. It's a parabola. So this cubic function, if you look back at the other example, you can graph it without even having to use your calculator. Starts at 0, 0, -1, -2, -2, -2, and then -3, 3. Goes down and then back up. Then on this one we go 1, 1, and then to 2, -2, and 3, nope, that's part of my parabola. So it looks like this. It should look similar to what you just did a second ago. We are going to graph the other one. So this is a parabola. If you're trying to graph it by hand, this one's not so bad because it doesn't have an extra x or number out to the side. It starts at 0, 0. It opens down because of the negative, and it is wider than normal because it's a 1/2 in front. You can graph -1, -0.5, and +1, -0.5. Then the next points over will be -2, -2, which, aha, there's a point of intersection, and aha, there's another point of intersection. And you can keep going if you want to, or you can just freehand it right now, because we do have enough points as far as like what we need. We've got two areas again, the area right here and the area right here. There are 3 points of intersection, and so that's going to tell us where to start and stop each integral. Like our first one, we're going to start at -2 and it ends at 0 because that's this first intersection point and the second one. And then we go from 0 to 2 for our next one. And again, we're going to have to look at which function is on top and which function is on bottom. And I don't know if I actually have enough room to write this, but we'll see. On the first section between -2 and 0, the parabola is on top, so it's going to go first, and then we're going to subtract our other function. And you can actually just subtract and like change the signs in your head before you write this down if you want to, and that would be fine. You just have to make sure that you change all of the signs in that second function. From 0 to 2, the cubic function is on top, so that's what's going to go first. And then we're going to subtract the parabola. and we're just going to work this out. So the first thing to do is distribute our negative and add like terms. So this time, because it's a negative x squared over 2, that's going to go with this negative x squared over 2. But because we're subtracting, that'll change all these signs so that they don't cancel. Drats. No, they do cancel. It's negative x squared over 2 plus x squared over 2. So those will take each other out. So that's nice. This one will be 0, negative 2, positive x cubed over 2, and negative 2x. And then let's see if the same kind of thing happens on this one. This will change to plus, and so we will again have these cancel because they're opposite signs, and we'll have negative x cubed over 2 plus 2x. We're going to plug these in. Well, actually, no. We're going to integrate with the power rule, and then we're going to plug in our numbers. So this is x to the 4th. When we divide by 4, since there's a 2 on the bottom, that's going to make 8. And then the integral of minus 2x, you add a power and get x squared, then you divide by 2 so that that 2 will go away. We want to do 0 and negative 2 for that part. And then we want to do the same thing, and it's going to look really similar. It'll just be negative x to the 4th over 8 and positive x squared. And we want to put in 2 and 0. You do have to be really careful to make sure you don't cancel out things that we shouldn't cancel, and that you pay attention, like right now when we're plugging in our numbers, because I'm going to plug in 0, and that gives me 0. And then I'm going to plug in negative 2. You have to plug in negatives into parentheses, especially if you're putting it in your calculator, because negative 2 to the 4th power is a positive number. If you don't have parentheses around it, your calculator doesn't know that that's what you're trying to do, so it gives you the wrong answer. Then on the second one, we're plugging in positive 2. And then the next part is just 0. So we're going to work this out and see what we get. We have negative 2 to the 4th power, which is 16. 16 over 8 is 2. Negative 2 squared is 4. And the negative in front will make that minus 4. Then we have 16 over 8, which is 2, but this time it's a negative 2. 2 squared gives us positive 4. And so we just need to figure out what this is. This is negative 2 inside, but there's a negative outside, so that's positive 2. This is positive 2, so that gives us a beautiful answer of 4. So between these three parts that we've done with area between the curves, that's pretty much the extent of what you might have to do with this, and then you add more to it later when we're doing other stuff. So that's part 3 of area between two